All right, section 1-2. Again, like I said, we're only going to do about the first half of it or so. And this may possibly be review, I'm not sure. Even if it's not, it's no big deal. I'm going to teach it from scratch. It's called the composition of functions, okay? So first of all, before we do the composition thing, and in fact, I don't even think, oh yeah, at the very end, yeah, the second half of this lesson today, we will do the composition stuff. But we're going to lead up to that. We talked about functions, remember using f of x as our way to write a function. What we're going to do is we're going to do some things with some functions. And we're going to add, we're going to subtract, multiply, and divide functions. And we have symbols for that. And it's pretty well, I don't know. Maybe it is self-explanatory, but I'm going to explain it to you anyway. So the sum, what are we doing to, what is that? That's the answer to a what kind of a problem? An addition problem, right? So here's some addition. So what if you had something written like this? F plus g in parentheses of x. That means you're going to have an f function, f of x. You're going to have a g function, g of x. And what are you going to do to those two functions? Just going to add them together. All right, pretty simple. This first part that we're going to do today is really basic. The composition is the stuff that's a little bit trickier you might not have seen before. But again, this should be something that you look at and you're like, it's kind of, I can kind of have figured that out myself. So here's what you would do. You would just take the f function, f of x, and just add it to the g function, g of x. Pretty basic, right? And what if you have a difference? What is the difference? What is that? What are you finding there? So it would be what? F minus g. You could probably do the rest of this yourself, what I'm showing you right here, right? Because we're going to do subtraction. So what do you think that looks like? If it's f minus g of x, another way you could do it is just take the f function and then do what to it? Subtract the g function from it. Very good. All right. Again, self-explanatory. It's kind of intuitive, isn't it? You probably look at this, you're like, yeah, that makes sense. What we're trying to do here. We'll do a couple examples just to show you. But what do you think the next one's going to be? Product, because that's multiplication. So let's go product. And so this would be f times g of x. And I bet you could figure out what that is, right? It's just f of x, what? Times g of x. That's all it is. And then we've got one last one, quotient, which is the answer to a division problem. And we're going to write it like this. Instead of the division symbol with a little line and a dot on the top and the bottom, how do we write division when we get a little bit more math? We do it as a fraction. All right. So what do you think this is? Pretty simple. This is going to be f of x divided by g of x. All right. So we had to go through that first. Now we're ready for an example. And you're like, well, I'm not really sure why you would use that. Well, these examples will clear that up for you, I think. All right. Everybody got that? Before I move it out of the way? All right. So here's an example. Example 1. Good place to start, right? Example 1. So here's what they give you. They give you a couple functions. They give you f of x, and that's 3x squared minus 4. They're just giving you this. And they give you another function, g of x, and that is 4x plus 5. And they ask you to do all four operations, okay? They ask you to add them, subtract them, multiply them, and divide them. All right, so the first one's going to say, it says find each function is what it says. I'm not going to write that down, but it says find each of these functions. So A says find f plus g of x. Well, what did we just learn? It just means you take your f function and your g function, what do you do to them? Just add them together. So here's our f function right there, 3x squared minus 4, and you're going to add the g function to it, 4x plus 5. Very basic, very easy. Just add those up. Remember, you can only add like terms. 3x squared. There's no other x, regular x's, so it's just a plus 4x. Add the regular numbers. Negative 4 plus 5 is plus 1. And then there you go. That's how you do that. Would you agree it's very intuitive? Meaning what? Meaning you could kind of just look at it without even me telling you, right? And probably figure it out yourself. Would you agree with that? Yeah, I think so. All right, what's the next one? We'll do these quick because it's pretty basic. F minus g of x. Now you got to be a little bit more careful on this one, because what is this? This is f of x minus g of x. So what's my f of x? 3x squared minus 4 minus the g of x. Now, what do you got to be careful about here? You're subtracting this whole thing right there. So what do you need? Am I just going to go minus 4x plus 5? Parentheses, right. You're going to go minus parentheses 4x plus 5. That is the key to that problem right there. All right. Once you do that, it's not that bad. So I've got 3x squared minus 4. Distribute the negative. That would be negative 4x minus 5. Right there is where a lot of people might make a mistake, because a lot of people might forget to put that parentheses there. So it's very important that we do that. All right, so the 3x squared goes, the minus 4x goes. Now this is a little different. It's negative 4 minus 5. That gives you a negative 9. That's what makes that different than that. And there you go. And then what do you think we're going to do now? We're going to go f what? Times g of x. All right. Whoops. Of x. What does that mean? Well, it means we take the f function, we multiply it by the g function. So what was the f function? It was 3x squared minus 4. Again, we're multiplying. What's that? Yeah, you need it in parentheses, both of them in parentheses. Multiplied by, and you don't really need the dot, I'm just putting it there. All right, times the g of x. And the g of x is what? 4x plus 5? And now you just multiply those together. How do we multiply this together? Just do a little FOIL. Okay, so 3x squared times 4x is what? 12x cubed. 3x squared plus 5 is plus 15x squared. Minus, right, because of that, 4 times 4x is 16x. And then another minus 4 times 5 is minus 20. Can you simplify anything here? Nope. Just circle it, and then that's it. It's just multiplying. Let's do one more. And let's do division. So they're going to say find f over g of x. Which means what? F of x divided by g of x. So where is f of x? Or what is it? It's 3x squared minus 4 over g of x, which is 4x plus 5. And can you simplify that? Can you actually divide that? Not really. All right, you just basically keep it like that. Now there's one thing that they do that's kind of important. When you're dividing and you have a variable on the bottom, what can the bottom not be if you have a fraction? It can't be 0. So this is the one little caveat, the one little thing that's a little bit different that you may not think about. So right here, not every single x in the world works for this. So what we have to do, whatever's going on here, I need you guys looking up here. All right, so what can this 4x plus 5 not be? 4x plus 5 cannot be what? 0. So we got to figure out what the x is in order to make the bottom into a 0. And we have to say x cannot be equal to this. So x can be everything in the world except for this. What do? Subtract a 5, divide by 4. So x cannot be what? Negative 5 over 4. So that's kind of important. It's not really my answer, but this is my answer, but this is part of it. Okay, it's just giving you some more detail that x can't be any number in the world. It can be any number. It can be any number in the world except for negative 5/4. All right, so that's one little thing that I probably might not remember. You might not remember, but you got to make sure you say that when you show it as such. Okay, enough of that. Now let's finally. We're going to skip example 2, and we're going to go right to the composition of functions. That's what this title of this lesson is. Composition of functions. All right, I'm not going to try to explain it to you. I'm just going to give you the definition for what composition is and how you do it, and then we should be good. And then we got a couple examples, like 2 examples to do, and then we'll be finished. How's that? All right, here it is. It's F, and then sometimes they say circle, so it's not a dot. It's not a multiplication. It's an open circle, all right? So it looks like an O, but it's a little smaller, okay? So people say it's fog, but it's really not. It means composition, F composition G. That's how you would technically say it. Some people say F circle G. Don't hear that too often, but I have heard that of, whoops, let's try this again, of X. What in the world does that mean? Did you guys do this in Algebra 2? Okay, good. So something new for you. So what does that mean? That circle means composition. And what does composition mean? It means like you're taking one of the functions and putting it into the other function. So you're not adding them together, you're not multiplying, dividing, subtracting. You're taking one function and then you're putting it in for the x in the other function. I'll show you what I'm talking about. So this is what we're going to do. We're going to go f of g of x. Right? So right there, it's kind of like your definition of composition. Right? It's f of g of x. So what we're going to do is we're going to take the g function and we're going to take that function and we're going to put it into the x for the f function. All right? Does that make any sense? It'll make more sense when I do this example. And then you'll look at it and you're like, oh, okay, now I know what he's saying. So let's see. So we're going to do 2 things. Let's write it right here. We're going to find f composition g of x, and then we're also going to find, g composition f of x. All right, so the first one, part A, is this one right here. Find f composition g of x. Well, we got to know what our f function is and we got to know what our g function is. So let's write those down. They give those to us. They say, I'll write it right here. They say that f of x is 2x squared minus 3x plus 8. All right, and then they tell you g of x is 5x minus 6. All right. So what in the world do we do here? Well, here's what I like to do for this composition. The very first thing I do is to write this little part right here down. F of g of x, because that's what it means. That's what f composition g of x means. It means f of g of x. So what do we do? Order of operations, what do you always do first? Stuff in the parentheses, right? And then you apply the other stuff. So what are we going to do first? We're going to stick that g of x in here. So what is the g of x? 5x minus 6, correct? All right, put that in parentheses, and then we're going to put the f out in front. So what we're trying to do now is trying to find what f of 5x minus 6 is. What if it was just a regular number? What if it was like f of 2? What would you do if I just said, what is f of 2? Well, you go to the f function, and what would you do? Put a 2 in for that x and a 2 in for that x. Agreed? But it's not f of 2. What is it? It's f of 5x minus 6. So what are we going to do? We're going to go 2 instead of x. What are we going to put in its place? 5x minus 6.
It's going to get way harder. This seems too easy. Can't get out.
Not that much harder.
Just plugging it in.
You're just plugging it in. Right. So that's basically,
That's so hard.
it's not hard. Didn't say it was. Did I say it was hard?
You said it wasn't intuitive.
Well, this in itself, like if I wrote that down, is that intuitive?
No.
No, of course not, okay? So I had to show you that, right? That's the definition, right? If I just said some word that didn't mean anything, you wouldn't know what it meant until I told you the definition, agreed? All right, so it's the same thing here. But actually working it out, it's really not that bad. You're right. All it is substitution. All you're doing is taking this and you're putting it in for the x on this. Now, sometimes the arithmetic, right, can be a little bit more cumbersome, right, because you might have something to the third power and you're taking like a binomial to the third power. And it could look ugly. But the basic concept is pretty simple, just like you said. It's really not that big of a deal. All right. So this one might be a little bit cumbersome too, because look what we're going to have to do. We're going to have to FOIL this thing, then we're going to have to multiply by 2. So it does get a little bit of work. So 3 times, whoops. So it's not 3 times x. What is it? 3 times 5x minus 6. And then plus 8. So what we're trying to do is just figure this out. So really, we've accomplished what we wanted to learn today as far as the composition, okay? How does it work? What do you plug in? What do you do? We did it. Now, this is just work. This is just manual labor right here, okay? Because everybody knows how to do this. So let's do it real quick. So how do we do it? 5x minus 6. If this is being squared, remember you multiply it by itself. You cannot just go 5x squared minus 6 squared. That's what a lot of people try to do, but you can't. But you guys have been doing math long enough, algebra 1, algebra 2. You know you have to multiply those together like that, all right? And then if you want to, we can just work this out. What's that going to be? Minus what? 15x plus 18 plus 8, yeah? So this is really the main work that we have to do here. So keep the 2 there. Let's figure out what this is going to be. 5x times 5x, 25x squared. 5x times negative 6 is negative 30x. The inside, right, negative 6 times 5x is also negative 30x. The last, negative 6 times negative 6, positive 36. Again, a little cumbersome, but it's not that difficult. We've done that plenty of times. And what's that, 26? All right. Then what do we do here? We could add some like terms, couldn't we? You just want to stick that here just so we don't have to write everything down again? All right, so let's multiply the 2 through this. So what are we going to get? 50x squared. This is a minus 60x. 2 times negative 60 is negative 120x. Everybody with me? All right, and then 2 times 36, what's that? 72. Minus 15x plus 26. All right, let me just write it right here. So let's add some like terms. The 50x squared stays right there. And the x is, what's that, negative 135x? Yeah? And then the regular numbers, 72 and 26, what's that, 98, right? And there you go. And that's your answer. Again, all this from here on down really had nothing to do with composition, did it? Learning anything new. That was just old stuff. It's just work, manual labor, like I said. This right here, knowing what to do with it is really important. So you take the g of x, you put it in to the f of x. Everybody good? All right, it's going to take me forever to remember what, 9:45. Oh, I only got a couple minutes. All right, enough of that. Let's do the next one. The next one's actually a little easier, just because of the math. So let's do g composition f of x. What does that mean? That means that's g of what? F of x. So what are we doing now? We're going to put the f of x right here. So this is g of, do you remember what our f of x is? It's off the screen, but I'll write it down. 2x squared minus 3x plus 8. That thing's supposed to be a 3. Okay. All right. So now we have g of this. What does that mean? That means we take all this stuff and we put it into what? Into the f function. To the g function. Sorry. This is your f right here. You're putting it into the g function. And what was the g function? It was 5x minus 6, correct? 5x minus 6. But what are we doing? We're taking that whole thing. It's just substitution. We're taking this whole thing right here and we're substituting it in for that x. So we just go 5 times all this stuff, 2x squared minus 3x plus 8. What's that? And then minus 6. Right, there's my 5x, and then you still got that minus 6. You got to put that right there. Now this math's a little easier. You don't have to do any FOIL method. It's basically distributive property. So it's 10x squared minus 15x plus 40 minus 6. Almost done. Whoops, why did I do that? 10x squared minus 15x plus 34. And there you go. That is your answer. Do you agree? Pretty simple. Yeah, sometimes the arithmetic might get a little bit tough, but there you go. So here's your homework. So it's section 1-2A. It's pages 17 and 18. And it's 11 to 21. 11 to 21. Nope. There you go. We're dismissing in 30 seconds, so. All right, everybody good? Okay. Have that done for tomorrow. And I think we're having a quiz this week too, right? Doesn't it say on the lesson plan? I don't know what. I don't have it in front of me. You guys took a picture of it beginning class. Quiz review. Oh, so no quiz this week, just review? Okay. Whatever it says on the lesson plan, look at it.